So I'm Dave Markland, Senior Product Manager here at Sierra Wireless. I've been in the wireless industry since the dawn of the wireless module 15 years ago. So for over a decade, there have been lots of early adopters deploying 2 and 3G cellular technology. And these applications, such as pipelines in oil and gas, wastewater management, utilities, and remote weather stations. And a lot of these applications didn't have power available, so they were built on solar power. Now, as 4G technology brings us LTE, these applications are moving from 2 and 3G over to 4G. The industrial environment gets all of the extremes. It gets the extreme lows in Canada and Alaska in terms of temperature, and it gets the extreme highs, you imagine southern US and Australia. It's not just about temperature. Often there's not a building to put the equipment in, so equipment gets exposed to dust, to moisture. In addition, the applications are often in hazardous environments, oil and gas, for example, and in this case, equipment has to be designed and rated appropriately. Power can also be incredibly challenging. Where you've got a solar panel, your equipment needs to be very efficient. Where you're running with the power source of a combustion engine, a diesel generator, a compressor, an excavator, you get very high, short, sharp voltage spikes, very long dips when the engines are starting. Product design for the enterprise environment just isn't suitable for industrial applications. So power consumption is absolutely key in solar applications. You want to optimize your power consumption for new installations to reduce the cost of your solar panels. But for existing installations where you're retrofitting equipment, if you can stay within the capacity of the existing panels, you save literally thousands on upgrade costs. Furthermore, the lower the power, the better the reliability. If you get adverse conditions like a spell of bad weather for a few days, if you've got lower power, you have a better chance of staying online. Industrial equipment is deployed with the expectation it lasts a decade or more, so it's really important to deploy the latest available technology at the time that you put it out there. And in that case, it just makes sense to use LTE. It also offers great bandwidth, but in these applications like SCADA, where you're sending maybe 100 or 200 bytes, the biggest advantage is the latency. You get very fast responses to your poles. If you're deploying in an area where you don't have LTE coverage yet, you can put LTE devices out, they'll run on 2 or 3G right now, and when the coverage gets there, they'll switch over and run on LTE. Traditionally in North America, you had to choose your hardware to match your carrier. So at the time you deployed your equipment, it was fixed to that carrier of choice. Now, we've designed the technology such that going forward, you just put the SIM card into the unit and it will automatically configure itself to that carrier, which is a huge bonus in the field, because if you subsequently want to change from one carrier to another, you don't need to replace your hardware, you simply change the SIM card. So our Raven product was a huge success in the industrial market. It had power consumption under a watt, and in the 2 and 3G era was deployed in a wide variety of applications. What we've done now is design RV50, where we've paired the best qualities of the Raven with LTE performance. Most LTE gateways on the market are drawing the order of 2 to 4 watts. What we've done is paired LTE with that Raven power consumption of under 1 watt. What RV50 gives us is an industrial grade gateway with LTE performance and the lowest power consumption in the market.